I'm guessing it's Hey everybody, how's it going? Here we have an A1502 MacBook that's not powering on. Let's de-corona this MacBook, open it up, see if we can make it work again, and figure out why it's not powering on. First thing we do is spray it with Corona. I mean anti-Corona spray. Yeah, we're not going to spray. Of course I don't have Corona in a bottle. I'm not producing Corona in a bottle. Man, this MacBook is really dirty. These are the types of MacBooks that Corona comes out of. Okay. So here we have an A1502 MacBook with an 820-3476 board. Let's see how many amps it takes. 126 milliamps. I'm guessing it's also a power good issue. Let's see. Take the board out of the case and see what's going on with it. I bet corrosion by Alsys power good transistor. What do you all think? Oh, this needs this damn Phillips that I don't have here. I never mind. I stole it from Kevin. Erica needs to replace her keyboard so that I can bring this back. My Phillips back. Where was I? Getting started on the board. That's... Okay. PP bus G3 hot is 1.5 volts. Do we have a short to ground on the PP bus? Perhaps that's what's causing this. Wait a second. 12.57 volts on PP bus here. So there's 12.57 volts on PP bus G3 hot on that side of the board. Now 12 on this side of the board. Interesting, and now we're down to 32 milliamps. Very strange, because before it was taking about 100. What the hell is going on here? What bumfuckery is this? Okay, let's go through our list. PPV RTC G3 hot, 3.3 volts. PP5VS5, 5 volts. PP5VS4, 0 volts. SMC's on because we got 12.5 here. You ho! Aha! I see it. Can any of you see it? PM sleep, GTFO. Bye. Say hello to this board, PM sleep S4L. You're coming back. I'm going to check and see what that cap was for in a moment. So in front of us is an 820-3476 or 820-3536. Same schematic, doesn't make a difference. I know the 3476 is a bit more difficult, the schematic to come by. That's a cap on PP5 ESO. Alright, let's do some scraping. Try to bring this pad back here. The pad is gone, so there's not really much I can do in terms of bringing the pad back. So I'm probably going to find a way to solder it to the trace after I rip the enamel off of the trace here. So that cap is going to go from being a horizontal cap to a vertical cap. Minor remodel. Just going to do a little bit of remodeling here. Some Eugening. Eugene. Okay. 33 milliamps. We haven't changed anything here. So now I'm going to have to entertain the possibility that there's still a short circuit on that rail. Wait, that's the ground side, isn't it? Yeah, 17 kiloohms. Okay, so this chip is for CPU vcore. Oh, God, no. Oh. Womp, womp. CPU vcore. Oh. This means my CPU got 5 volts. Actually, no, my CPU got 12 volts, because this chip is controlling these transistors that send 12 volts to the CPU. Alright, so we're probably going to find some more liquid here. At least 12 volts is better than 15.6. I should probably drink some water, actually. Yeah, I'm the worst at social media. I don't have a Twitter. I don't have a Facebook. I don't have an Instagram. I don't have a LinkedIn. The only place you can find me is here. And I recently stopped reading my comments for the good of my sanity. I really don't want to believe that PM Sleep S4L is still missing. I kind of wanted to believe that once I fix this, that would be it. I don't want to believe it. This sucks. Oh, I just wiggled the charger and I'm at 200 milliamps. Ho ho. Are you serious? All I did is wiggle the charger and I'm at 290 milliamps. Okay. Let's see, is PP bus present? Okay, maybe it's getting into an SO state but not staying there because that thing to control the transistor is damaged. Maybe that's what's going on here. Wait a second. 5 volts is not going to the chip because I ripped off the pad. Oh, you dumb motherfucker. I'm a fucking moron. How did I not notice that? Oh. Son of a bitch. Son of a bitch. Wow, that was really stupid. See? Look. This is PP5 ESO. It's coming down here. The pad was corroded, so I scraped it, but without realizing that it's not that PP5 ESO is going from here up there. It's going from up there to down here. How is the chip supposed to get any power? Of course it's not going to turn on. CPU vcore is not going to be present because the chip that is controlling the transistor that sends PP bus G3 hot pulses to the CPU to give the CPU 1.7 volts of CPU vcore. Didn't have any power to turn on. Of course it's not going to turn on. Wow, that's total smooth brain moment. I feel like a koala that's trying to figure out what to eat, but the leaf is on the ground rather than in the tree, so he just kind of cries and sits there until he starves to death because he's too stupid to tell that he could. OMG. Man, if I can fix Macs, I'm telling you. If I can fix a MacBook, anybody can. There's no excuse for geniuses to be this incompetent. Yeah, that's the sad part too. That's the really sad part. It's not like Apple's repair business model looks bad in contrast to, the Society of Engineers, the IEEE, union electricians or some shit. Some dumbass that cuts a trace to a chip that's needed for it to turn on, doesn't put it back on, and then wonders why the computer's not turning on. The bar is not high here. The bar is not high, yet Apple still can't get it. Alright, so we got a nice little jumper wire in place. That's some enamel jumper wire. I'll replace the chip as well. I'm not going to reuse the old one. I shouldn't even be thinking about reusing the old one. Is there seriously a cap under that? There was a freaking capacitor under there, or a piece of something. What the hell? Wow, there was a piece of molten junk under there that wasn't melting. Interesting. And lower that wire a little bit so it doesn't stick up. Get rid of that edge piece. Give it a sec to cool down using rapid cool technology. This is rapid cool technology. My fume extractor. All right, give me 550 milliamps, 550 milliamps, 550 milliamps. Ha ha! Again! Fixed! Fan spin! All right, let's go over what was going on with this machine. So we had liquid damage on this cap between PP5 ESO and this chip. Now there's a chance that was shorting it to ground, but also this connection being corroded here, the cap was really a red herring. The cap most likely wasn't my problem. The problem is that the path between PP5 ESO and here was broken. This is a phase for CPU vcore. What do I mean by phase? Great question. If you zoom out, this over here is a controller chip. This is going to control these transistors, which are sending 12 volts to the CPU. So here is the output, PP VCC SO CPU. It says 1.85 volts, but its input over here from these transistors, these transistors are going to be outputting slices of PP bus S5 high side computing, and PP bus S5 high sense computing is also known as PP bus G3 hot. Yeah, I'll show you where I find that here. Here we go. Yeah, so PP bus G3 hot goes to a current sense resistor to become this. That's why I use the terms interchangeably. PP bus G3 hot is also easier to say than all this crap. Anyway, if we go back to where I was, Q7310 area, if you take a look, what this does is it's going to take slices of 12 volts and turn it into 1.8. So these are transistors. A transistor is like a switch, except the transistor is a switch that you don't flip with, your finger like a light switch. It's a switch that you flip by sending electricity to it. So if it sees electricity on its gate, it'll let stuff through. If it doesn't see electricity on the gate, it won't. Or if it's the opposite type of transistor, then it'll work the opposite way. But you get the idea. It's like a light switch that is switched electronically. Now, the way a switching power supply is going to work, and the way this entire section over here is going to work, is it's going to take slices of PP bus G3 hot, which is 12.5 volts, cut it up into sections, and then send it off, and then it's going to get turned into 1.8. So the way this works is kind of like averaging. So if you have 12 volts and you want to turn it into 1 volt, what you do is you send a little bit of 12 volts, then you turn the transistor off, and you send a lot of 0. Then you send a little bit of 12 volts, then you send a lot of 0. Then you send a little bit of 12 volts, then you send a lot of 0. Now, the CPU is not going to want to get punched in the face with 12 volts every time, because if you're getting like, ow, 12 volts, ow, 12 volts, ow, 12 volts, your CPU is dead. What you want to do is you want to even it out, and that's what's going to happen with this inductor over here. So the inductor is going to take all those pulses of 12 volts, and when you have the inductor over here, that's going to smooth it out. Then you have a bunch of capacitors to ground, which are also going to be smoothing this out. That's going to be on another page of the schematic. Then what you wind up with is instead of a bunch of ow, ow, you wind up with a steady 1 volt, which is just like, because like imagine you're trying to fall asleep in class. Like, this you can do. Steady, low pressure, rather than That's the idea. So this transistor over here, this set of transistors, is going to create one phase. But since the CPU is going to need a lot of power, what you need is multiple phases. So over here, this is going to be making 1.85 volts, but this may not be making it at enough current. You may need more current than that. So that's why you have this over here. This is going to be phase 2. Now, on the older machines that I remember, the transistors were directly controlled by the CPU vcore controller chip. So what this chip over here is going to do is it's going to tell the transistors when to turn on and off. But here it seems like you got this as a middleman. So you have this chip, which speaks to this chip. This chip is the CPU vcore controller, the ISL 95826. That controls this, and then this controls that. Same thing here. This chip controls this chip. This chip then controls those transistors. Those transistors send pulses of 12 volts through this way. The coil is going to then average that out, and it's going to wind up being about 1.85 volts. And then somewhere down the line, there's going to be a bunch of capacitors. Yeah, if you take a look on the schematic, the board view over here, you'll see that there's a bunch of little capacitors everywhere. And that's going to smooth it out, and you'll get a nice, even, happy 1.85 volts. Now, only one of those phases is working, not two. So the reason I was probably getting 255 milliamps, 120 milliamps before, rather than the whole thing, is it actually was turning on. But it was only turning on half of its brain. Kind of like after I got my concussion when I was riding my bike 2 years ago and I went over that stupid oily grate. Half of my brain was on. So I'm still alive, I'm still breathing, but I had no idea where I was or that I went to the gym that day. Same thing is true here. The reason that I was only taking 100 to 250 milliamps rather than the entire 5 to 600 is because only half of the CPU vcore phase was working. But now it's all working. And that is my scientific definition for the day. I hope you've enjoyed your class with Professor Rossman. That's it for today. And as always, I hope you learned something. I'm going to take a break, get some food, shoot my employees with some Nerf guns, because why not? And I'll see you all in the next video. Thank you for watching. And as always, I hope you learned something. Bye now.